Thanks for joining the session, right? So my name is Wim Henderickx. I work in Nokia as the head of technology and architecture. And I'm also the vice chair in Nefio on SIG automation, right? So I didn't use Nefio in the title, but the talk is very tightly related to what we are doing in Nefio. So the talk is about navigating dependencies in Kubernetes deployment, right? And so this is an initiative that was coming within the Nefio environment, where we basically said, so there was a few people that are deploying, let's say, Kubernetes workloads. And one of the challenges that we have is there is lots of dependencies that you actually have to figure out. So for example, the idea that we had here was, okay, so we are in the world of 5G, so we want to deploy 5G, but then we have a lot of things that need to be taken care of. And how do we ensure that we can do that without, actually in a fully automated way? So basically, I want to deploy 5G. I have a bunch of requirements on infrastructure, as an example. How do we ensure that we can deploy and automate and resolve these things in an automated fashion? That's kind of the problem space that I'm talking about. Now, it turns out that we talk about this in the context of infrastructure, right? But this problem is actually, or I think the solution that we have for the problem is so generic that it actually applies to any software that you deploy within a Kubernetes framework, right? And so if you look to the technology under the hood, we didn't want to make it specifically to that use case. So it's actually built in a way that is generic such that we can leverage in anything, right? So, but where do we come from? It's like we come from a world where our systems are a black box, right? So we came from a world where everything was hardware controlled by the vendor, right? Everything with respect to security, hardware, acceleration, and what have you, was all controlled by the vendor, right? And which is what I call the black box side of things. And now we move into this cloud native space where everything is microservices, and actually the vendor only cares about the app box, or still the black box in the middle, but all the blue things around you are actually controlled by other people. And it's even like this, that it's not only a single person or a single role in an organization, it could be even multiple roles in an organization that take care of different discrete components of that puzzle, right? And so it turns out that the challenge is that most of these things are not communicated very well, so that means that there is a lot of hidden requirements, so things that we only figure out when we are deploying. And as a result, it's high effort, high frustration, and what have you, right? So the question is, can we do better, right? And so what the people asked us to do is basically the easy button, right? To say, okay, because the goal is, I want to deploy something and figure it out for me, right? It's kind of the same way as you compile a piece of code. You have a bunch of dependencies of libraries that you are depending upon, and somehow there is a system that figures it out. You actually have to look at this thing in the same way, right? So it's kind of a compiler, if you will, that actually says, I want to deploy this thing, and all of a sudden, all the magical dependencies get resolved for you. Wouldn't this be nice? Right? So that's kind of where we are trying to go. And of course, we have to do that in a way that this is consumed by multiple people with different roles in an organization and stuff like that. And ideally, it's fully automated. But we all know that some, let's say, roles in an organization don't allow that. So we also have to take care about things of manual approval or manual intervention. But at least that it's the triggers to say, I want this to happen, is done through an automated system, but still a human or a ticketing system can be involved to basically give you, yes, go for it, right? So, or at least there was a validation step that we can use to say, yes, I'm okay that this change is going to happen, right? But we want to design it in the way that we can do it in a fully automated way, right? But allow for that human intervention if people are not really comfortable or trusting the automation. yet, right? So that's kind of the scene, right? And so if you look at it, so the question is, how do you do this, right? And so one thing that you can do, and that was a big debate when we started Nephew, right? So we said, okay, we can describe all of this stuff, all the dependencies and all CRDs and stuff like that, but we decided, I think Tal was one of the persons that basically said to us, don't do it, we have a concept of a package, right? And let's use that as a way to describe or actually express all the different things that we need together, right? So we ended up going for an approach where we basically said, here is a package. So it's a collection of KRM resources, right? And what that KRM is depends on what you want to deploy, right? So think about the software dependency tree. So you have a piece of software that has a bunch of libraries. Each of those KRM functions or KRM resources are actually something that you want to be, that you're potentially depending upon, okay? The second thing that we did is so ports as a system, right? And what I did in this prototype is basically I built it, I didn't use ports, so I built my own implementation, but we actually have programmatic access to the content of that package, right? So in other words, you now have a system that can see what is in that package and then can look at it, and given that we use KRM and the schema of that KRM resource is defined, you can actually figure out dependencies, right? So what is a package? So what is the content of a package? So this is just an example that we use inside of Nephew. So here we have cluster context, we have interfaces, and we have a DNN, right? But there could be other resources into it, right? Now, if I have an API that is able to access that data, and I can figure out what the content is, without understanding all the nitty-gritty details, I potentially can resolve dependencies, right? Now, it turns out that if you look at how Kubernetes is structured, you actually have what we call core resources, right? So if you install a Kubernetes cluster, these resources are all available. So like a service, a deployment, a replica set. If you have a Kubernetes instance, in every distribution, you get those. And you have a way to extend it through either CRDs or API service concept, right? So if I know that there is a CRD inside of a package, I know that this package is expressing a new API that was not available inside of Kubernetes, right? And if I have another package on this side that is leveraging that API, I know that I'm depending on it, right? So in other words, if I have one package to say, I'm Multus, and I will install Multus, and I install the Multus CRDs, and I have another package that says, I want to use Multus, I know that this package is depending on that, right? So if I install this guy, I need to install this one first, because otherwise I cannot leverage the API, you see? So it's very easy. And so the first controller that we built is actually a controller that actually looks at all the packages that you have, right? So think about all the catalog like blueprints which was shown in the demo of Google, right? So you have a bunch of blueprint packages. And let's say I have a controller through the Porch APIs that can actually look at all the content and figure out what is the content of each of these packages, and if I have CRDs or I have extensions, and I have other packages that are depending on it, I can build a dependency tree from each package to another, right? And if I make that information available, so this controller, basically what it does, it just looks at all the content of the package and makes the dependencies that each package is depending upon available inside of the Kubernetes API system, right? Now, someone else will then use that to figure out who is depending on what. So if I install a certain package and you see a dependency tree through a DAG, you can actually figure out what I need to do first, and then second and third, and so on and so forth. So an example of this is So this is what I showed during the demo a couple of months ago, is I want to install a cluster. So each of these bubbles, by the way, is a package, right, of some sort. And each of these packages have a set of KRM resources inside of it. And actually, each package has a dependency based on the arrows. So in other words, if I have that available from each of them, I can actually build a dependency tree like you see here, right? So if I install the left kind package, I know that I need all the other stuff, right? So in other words, if I don't have cert manager installed, or I don't have Core installed, or I don't have the other packages installed, it means there's no point in installing the left-hand guy, right? So in other words, I need to get the other things going before I'm able to I'm able to install the original package. Make sense? Right? So as such, what we did is we said, okay, by going through that whole process and flow, right, if we have a system that can do that and do the recursive resolution, all of a sudden, I can actually build a system that does that in an automated way, right? Now, of course, we wanted to have an ability to then go through customization and approval and so on and so forth. So we actually built a system that does this resolution in a recursive fashion, right? Make sense? So far? So it's actually a very small building block that actually does that whole recursion flexibly. I don't know, I'm running a bit. Is there some water or something like that I can tap into? Yeah. Now, so the thing is then, of course, we have an ability to do that and make that pluggable, right? So in other words, what we also then did is we have a way to do the installation. Yeah, I need some water because my voice is very dry. Yeah, okay, thanks. I'll wait a bit. Yeah.
Can I ask a question?
Yeah, go ahead, yeah.
So on the dependency management, is the dependency inferred or is the dependency explicit in the package?
So it's inferred. So in other words, every package that we have, right, we figure out the dependency automatically between themselves, right? So in other words, by looking at the content of the package, I can actually figure out the dependencies between all the other packages, basically.
But can I also explicitly define dependency?
Yes, you can. So we added that. So for example, in the demo, what you see is that if you cannot resolve it explicitly or implicitly, you can actually build your own dependency CR into it as well. So that's, we made that available to, because it is true that not everything can be expressed automatically, right? Yeah, so thanks for my voice. A bit better, yeah. So, yeah, so in other words, what we do is we, on the left-hand side, so we instantiate the package revision. The scheduler here figures out the dependency, and then once that is done, so through a condition, we basically then allow the left-hand side to happen. So in other words, also the system is basically built how Kubernetes schedules a pod, for example. There is a lot of, you need a volume, you need a network interface, you need a bunch of things. So that's also implemented using conditions. So we use the same technique here to actually express that the next controller can actually function. So in other words, if you instantiate the package, right? So the light blue thing, the first thing that happens is the scheduler figures out through the dependency tree what are all the dependencies between each of the other packages, right? And then instantiates them or not, right? So that's the first thing that happens. If that condition is met, as for example, if we schedule kind on the left-hand side, right? then if none of the others are installed, it will hold, right? So the scheduler will basically say, I first need to install cert manager and then the next and the next and the next before I can actually install the next section. So in other words, the condition that, so the scheduler basically says, yes, I'm okay when the dependencies are resolved, right? The next thing then what happens is condition B, which is the packet processor. I'll explain in a bit what that guy does, right? Then you have the approval controller that basically automates the approval, or it has to be a human, right? So it can be either a machine or it has to be a human. And then there is the installer, which basically installs the content of the package. If you use GitOps, which is what we do in Nefio, right? You actually use that controller to basically do the installation, right? So that's kind of what happens over there, right? Sorry, my voice is a bit, it's probably jet lag. So yeah, basically that's the process. Now, the next thing that and the installer itself is, so I did the implementation on config sync, but you can use Argo or Flux or whatever, or if you don't want to use GitOps, you could actually implement it using your own system, right? Now, it's good to do software installation, but in essence, what you typically see is that it's not just the blueprint as such. You also want to vary the content of that package depending on where you deploy, right? So it's not just I'm deploying this thing. You also want to sometimes revert some parameters, like I want to have a specific IP address, I want to have a specific VLAN, I want to have specific parameters for that environment where I deploy that thing, right? So the question is, how do we go about that? And so the system allows you to what I call context, so provide context when that package gets installed, which is basically the purple thing. And then what I didn't say so far is the packet processor controller is something that actually is able to take that context and use it to modify the content of the package based on the input that we get, right? Make sense? Now, inside of Nefio so far, we are using KPT to do so. And as a result, you actually had to write code for all the functions that we actually did. So I actually changed that. So, and I'm using Kform as a tool to basically do the replacement. And so Kform is a mechanism to, it's basically an alternative towards what KPT does, right? But in a mode that you actually don't have to write a lot of code. So it's basically a low-code, no-code system that allows you to vary that content through what I call an expression language somehow, right? And Kform as a tool is basically inspired by Terraform. The difference is that it uses 100% KRM, right? So in other words, in Terraform, we have our own language to basically define the schema. Here, because we already have schemas with KRM, there's no point in basically doing another schema system, right? And so the way, because so far we have dependencies between packages, but you also have what I call runtime dependencies. For example, if I need an IP address and there is no IP subnet allocated for that particular cluster, there's no point in going further, right? So you also have what you say runtime dependencies that has to be resolved within the package to be able to then vary the content. So that is done using Kform as a system. Wait, let me, I don't know what's happening with my voice. And so there is a business logic that actually runs inside of Kform that actually builds a dependency tree between all of those resources. The other, so nice thing, if you look to how Kform is built, it uses a provider to access an API, right? So in other words, if you want to get an IP address, which is typically not provided within the package itself, you need to reach out to an API to get some of that information. it's done through a provider, right? So it basically, a provider is a flexible way to actually get access to an API system. Now, it turns out that because we use 100% KRM, we actually don't need just one provider, right? So it's basically a provider that basically accesses the Kubernetes API server. But of course, it is like this, that not everything is potentially built through Kubernetes resources. For example, if you want to access a system that is not KRM based, so how do you do that? So you have basically two ways. You can either build a controller or a controller equivalent, right? That actually maps that API into KRM, right? Or you can build a provider that is specific to that API. So you have both modes. But the nice thing is that the tooling itself, so if you compare, for example, towards KPT today, you actually have to write a completely own function to be able to do so, whereas here, it's actually the provider that takes care of that. So it's basically, I believe, more flexible system to do that customization, and also done in a, what I call a low-code, no-code fashion, right? So in other words, Kform is a way to actually resolve that dependencies that you need to have all the resources that are listing within that package and that you need to do the variation and modification. It actually does that all combined within a single system. The other nice thing, I think, is that it's both a client-side as well as server-side tool. So in other words, to be able to test your business logic, right? You actually can test that completely on the client side. So in other words, as a developer of a package and you want to vary the business logic. So for example, the example that I have here is what Kform does to basically get an IP address, so an IP claim, right? So an IP claim is basically, I want an IP address, and I want to actually have it in a specific network instance and with these selectors, right? So this is actually the KRM resource that Kform uses to go to the API server, fetch an IP address, and then that data is then used later on through the cell expressions that you see inside to actually then modify the content of the package and get your business logic as a whole. So basically, this is just one KRM within the package. So a package can consist of way more data than just this, but this is just an example of one that actually goes to the API server and can fetch data, let's say, externally, okay? So in other words, so Kform is a tool that helps you in a very, let's say, user-friendly way to modify and vary content of packages without you having to do a bunch of code and development and stuff like that. Now, the whole system is pluggable. So in other words, I use a certain, so I use in the packet processor, I use Kform, but for example, if you as a user want to say, I want to use KPT, or I want to use Ansible, and I want to use Terraform and other combinations, you just build your own pipeline of things, and each packet processor can be its own technology, and you can basically make it pluggable. So in other words, besides resolving all the dependencies, I also try to make the system pluggable to be able to get different needs, and people sometimes have a bias or have a preference of a certain tool compared to others, right? So the system should be flexible to allow you to pick and choose depending on what you're trying to accomplish, right? So that's also being taken care of. Now, putting it all together, so first of all, the package context that we developed inside of Nefio, I think is a very flexible way to actually compose systems, right? Because the alternative is building massive CRDs and schemas and dependencies and stuff like that. So it's a very flexible way to actually compose that thing. Then with this recursive scheduling and package resolution, actually it's a very simple mechanism to actually do this, right? So that's the other nice thing, I think, about it. And the whole framework is pluggable to be able to do so. And what is important, though, if you look at the design, the packages in my view, should have a clear owner within the organization who is responsible for it, right? So if you, basically, because how you structure the package is your choice. So we give you the tool to do it, but if you organize it in such a way that each package has a clear responsibility in the organization, you also know who is the person or who is the team that is responsible for the approval, you see, right? That doesn't mean that that package cannot basically get dependencies or get requirements or conditions set up towards other teams, right? So you can, for example, say if I want to deploy a 5G and I want an IP address or I want to create a VLAN somewhere, which is the infra team, right? That doesn't mean that the package cannot express a requirement to another person to basically say, I need that. But the approval of the package, once that dependency is resolved, the person or the thing that is approving it should have one owner, you see? And as a result, that is the team, whether it's a human or whether it's a group, that would be the team that actually does that, that approval, if you will, right? So if you organize your package in a way that have one owner within the organization that is responsible for that, that becomes table stakes, if you will, right? But I believe, yeah, so I think we have built a framework that allows you to get to the easy button, if you will. And yeah, maybe I open it for questions if there are any. And yeah, Tal, go ahead.
Do I need a microphone?
No, it's okay.
This is great. I love it. I've been thinking in a lot of the same directions. So two comments, but
sure.
Helpful comments. So one, get inspired by Tosca a little bit. So Tosca has this feature called requirements and capabilities, which is exactly about matching these with kind of first-class relationships and creating these DAGs.
Sure.
And it has kind of a filtering language. You can specify requirement and something to fulfill it according to whatever capability it has. So it's kind of an object-oriented type system. But I'm thinking a step forward, and I think your project is where this can happen. We're missing an expressive dependency description language. Right?
Yes.
So we have policy description languages like OPA, but the issue is that dependencies aren't always hard. Sometimes you have a hard dependency. I need this.
Yeah.
Supply me this, and you might have a few different providers that can give you this. But many times, in telco especially, we have soft dependencies, conditional dependencies. Like I work best with NUMA pages that are D-sized, but if you have a cluster with half of it, I can also work well, but I might need something else instead, right? So you end up having kind of a functional language that describes kind of if-else with preferences and weights, and you resolve it according to between what your ideal is and versus what the reality can provide you.
Sure.
And this gets even more complicated when you're deploying, say, several workloads at the same time, right? So which workload do you prioritize, right? You're deploying 5G core. You have 6 different components, right? 6 different network functions. One might be more critical than the other. So not only are the dependencies in the low level of the network functions themselves, but the topology itself can have certain priorities as well.
Yeah.
This is exactly where once you isolate have a component called a reconciler for dependencies, that's where all that logic can happen.
Correct, yeah.
So we didn't really have this until now, but I think we're starting to think in the direction, and we'll finally be able to solve this problem of dependency satisfaction, I think, in a much more comprehensive way.
Yeah, correct. So yeah, and I'm not saying that all the problems are solved yet, right? But we are trying to get towards a level where we are getting more towards that dependency tree and have the ability to express. But okay, so this is a first, let's say, prototype, if you will. Of course, we will have to include a number of capabilities to make it better and see how this can be resolved or how more live uses can be actually covered during the deployment, right? Yeah, Alexis, go ahead. We are done. Red.
I have a question. So about, again, my question that I had earlier on how do you identify dependencies? So
yes.
You mentioned that they're inferred and they could potentially be so explicitly defined. The question I had is on the package validation piece that you have. The scheduler, exactly the scheduler. Because if I understood correctly, the scheduler is responsible to build that.
The DAG, yeah, it does the DAG, yeah.
Now, what if something misses? What if I miss a dependency? So
Yeah.
can I rely on the scheduler to do also the validation of that package?
Wait, so what the scheduler does, it basically, it resolves the dependency. If the dependency is not met, it will basically tell you why it cannot continue.
So it acts a little bit as a validation.
Correct, yeah.
Good. Okay.
Yeah.
That's what I meant.
Yeah. What I did not cover yet, right, and that's the next thing, so for example, software updates. So for example, I want to update this package, yeah, so it's done, we are running out of time, but like, upgrades of software, you now know all the dependencies. So there's a lot of stuff, I think the foundation has a lot of legs to build upon, because it's also very pluggable and stuff like that, so all of these components are changeable. So there is a number of capabilities that still need to be added, but I think we are running out of time. So let's discuss offline maybe.
Well, ultimately my comment was maybe we can have a package validation piece in front of the scheduler.
Also, yeah, so yeah.
Separate the concerns.
Yeah, so one of the things that I did not add here, but so the like package validation is actually added there. So I need to stop, by the way. But these are pluggable things. So you could add the package validation thing on top of the system and go for it, right? But yeah.